Hello, this is Dr. Parcell, and I am just going over four concepts that I have noticed historically students struggle with during test one and also on the practice test. So I figured let's go ahead and go over those concepts. Okay, so here's the first one. A cash prize, let's see if I can make this a little nicer here, of $3,200 is to be awarded at a fundraiser. Okay. If 1,600 tickets are sold at $6 each, find the expected value and round your answer to the nearest cent. Okay, so I like to make a chart when I'm trying to find expected value. So let's make a little chart here. As a matter of fact, give myself a little more room. Okay, so we've got our gain. Let's try that again. So we got our gain. It could be a gain or loss, but that's going to be X. And then we have our probability of that gain or loss happening. Okay. All right. So got a couple things going on here. You're either going to win or you're not going to win, right? So if you win, you get $3,200. So that's going to be a gain. But you had to pay $6 in order to be able to play that game. So 3,200 minus 6 would give us 3,194. That's what you could win. All right, now there's only one ticket that you could possibly be the winner out of 1,600. So if you won, you'd win $3,194. That's what you would win. You have a 1 out of 1,600 chance of winning. Now, if you lose, you're going to lose that $6, right? And the chances of you losing are 1,599 out of 1,600. All right, so let's see here. This right here, we're going to put 3,200 minus 6. And here we're going to put 1,600 minus 1. Okay. All right. So in order to calculate this, we're going to multiply the gain or the loss times the probability of it happening and add it to the gain or the loss of the probability that it didn't happen. And that's going to, if we add those together, that's going to help us find our expected value. Okay. So 3,194 times 1 over 1,600 plus 6 times, and this is money, so we're going to put the dollar sign, times 1,599 over 1,600. Okay, so I'm going to use my cell phone just so that I can have a calculator that hopefully is similar to what everybody else is working with. So I'm going to turn mine sideways here. Okay, so first I'm going to do 1 over 1,600. 1 divided by 1,600. Get that decimal, then multiply that times 3,194. Okay, oopsie, it'd be helpful if you could see that probably. So let's see if I can make that happen. There we go. So I'll do that again. I did 1 divided by 1,600, got a decimal and multiplied that times the winnings 3,194. So that gives me 1.99625. We're going to add that too. Now this $6, keep in mind, is negative. All right. So I'm going to go back up here and just make sure we know that this is our loss. This is what we're going to lose, $6. So it's really negative. So I don't want to try to fool with trying to make my calculator, figure out negative numbers. So I'm just going to do 1,599 right here, divided by 1,600. Get that, multiply that times 6, hit enter. But I know that this is a negative 5.99625. Okay, so I'm going to clear this out and take 1.99625 and subtract out, because adding a negative is the same as subtracting. Subtract out 5.99625, and I should have my expected value. There it is. So my expected value is negative $4. Okay, so that's a concept. This is actually the number one missed concept on test one. So don't fall into that trap. All right, what's the number 2 most missed concept? All right. So here it is. So we've got 52 cards in a standard deck. Suppose a card is drawn at random from a standard deck. The card is then shuffled back into the deck. All right, so that means the card went back in and we reset. Then for a second time, a card is drawn at random from the deck, and then that card is also shuffled back into the deck. Finally, for a third time, a card is drawn at random from the deck. Okay, so we have three different things happening here. So I'm going to organize my thoughts. What's the probability of first drawing a red card, then a 5, then a black card? So probability of red, let's do that first. Well, there's 26 out of 52 reds. Okay. We're going to multiply that times the probability of getting a 5. Well, there's only 4 5s out of those 52 cards. And I'm using 52 as my denominator because the cards keep getting put back in the deck. Then the probability of getting a black card is 26 black cards out of 52. All right, so we're going to multiply these together. I'm going to see if I can do this with my calculator here. Right. Trying to get it to turn sideways here. All right, so 26 divided by 52 is 0.5. So I'm just going to put a little 0.5 right here, which means this is 0.5. And then I'm going to clear that out, and 4 divided by 52 is a whole long number. So I don't want to write that down. So what I'm going to do is take that, which is this, multiply it by 0.5, and then multiply it again times 0.5. Okay, so I'm getting a 0.01923. And let's see here, how far do they want us to go out? 4 decimal places. So 1, 2, 3, 4. So we're going to go with 0.0192. So it's a 1.0192, a 1.92% chance of this happening, where you would draw a red card first, then a 5 second, then a black card third. Okay, so that is something that's very missed. We're not going to let you get caught with that one. So let's see here. We have another concept here. So this is the third most missed problem. Okay, it is estimated that during the past year, 26% of all adults visited a therapist and 46% of all adults used antidepressants. It's also estimated that 22% of all adults both visited a therapist and used an antidepressant during the past year. Okay, not necessary that you have to do this, but I'm very visual, so I'm going to make a Venn diagram to sort of help me sort this out here. In fact, I'm going to turn it like this here. All right, so we got two things going on. We got people going to therapy, and then people needing antidepressants. Okay, so here's how I would create this. When it says it's estimated that 22% of all adults both visited a therapist and use an antidepressant, we know that and means the overlap or what's in common. So we're going to put that 22% here. So that's the and part right there. Okay, 26% of all adults visit a therapist. So I need 26 in this particular bubble here, but I already have 22% here. So 26 minus 22 leaves me 4% here. So 4% plus 22% gives me 26% of adults visit a therapist. Okay, 46% use antidepressants. Well, 46% needs to be in here, but I got to take out 22%. So that's 24% right there. Okay, so you don't necessarily have to do this, but for me, it really helps visually. Okay, so let's answer these questions. Okay, what is the probability that an adult visited a therapist during the past year given, gonna circle that word, that he or she used antidepressants. Round your answer to the nearest hundredth. Okay, we know that after the word given, this is conditional probability, that anything that happens after the word given becomes your denominator. So for part A, my denominator needs to be that they used antidepressants. Okay, so we know that this is our antidepressant bubble, and we know that 46% used antidepressants. So that's 0.46. Okay. Out in front of the given becomes your numerator, the probability that an adult visit a therapist. Okay. So in my bubble here that I used antidepressants, 22% got therapy. So 22 is my numerator. So now we're going to figure out what 0.22 divided by 0.46 is. So let's clear this out here. 0.22 divided by 0.46 is 0.478. They want us to go around to the nearest hundredth, excuse me. So this should be 0.48. So a 48% chance that you would select somebody from this particular scenario and that they had visited a therapist during the past year, but upon the condition that they had used antidepressants. Okay, second part B. What's the probability that a randomly selected adult who visited a therapist during the past year also used antidepressants? Okay, so let's see here. I'm going to make this table a little tinier here. So they didn't use the word given, all right? So I was looking for that word in that problem. So probability that a randomly selected adult visited a therapist during the past year. Also, so and I'm gonna cross this out and put and used antidepressants. Okay, so and means that there's an overlap, right? We know that the and happens right here with the 22%. So that's going to be my numerator, 0.22. So these are people that have visited a therapist during the past year and also used antidepressants. So 0.22 is the and then that they went and had therapy is 22% plus 4%, so that's 26%. Okay, so we're going to do 0.22 divided by 0.26. Okay, 0.22, whoopsie. 0.26. What's the chances of that happening? And they want us to go to the nearest hundredth. This is 0.846, so we're going to call this 0.85. Okay. So I think this might have been the third most missed concept. And then we're going to look at the fourth most missed concept, and that's our last one for today. Okay, here's a table showing all 52 cards. A card is drawn at random from a standard deck. The card is not put back into the deck, so beware. And then a second card is drawn. What's the probability that the first card is a diamond and the second card is a black card? Okay, first card of diamond. We know we got 52 fresh cards to look at. There are 13 diamonds. Okay, but now let's say you got that diamond. You did not put it back into the deck, so now our denominator is 51. Now what's the chance of getting, what they say, a black card? Well, we know there's 26 black cards. Okay, and they want us to round this to 4 decimal places. So here we go. See if I can get my calculator on here. Okay, so 13 divided by 52 should be a quarter. Yep, so 0.25 times, let's clear this out. 26 divided by 51 should be, oh, that's a long decimal. So we're going to take that and multiply that by 0.25. Okay, so that's going to give us 0.1274. We want to go out to 4 decimal places. So what's after the 4? There's a 5 there. Okay, so 1, 2, 3, 4, put up a door. 0.127, we're going to go 5. 0.12 or 12.75% chance that you would select a diamond. Then let's say you throw it away and then you then go back in and select a black card. All right. All right. Hope this helps you all and good luck on your test. Bye.